Okay, ch11 capacitors. We're talking about the storage transient. So this is a circuit that we're looking at. An ERL circuit with the switch open. When you close the switch, this is the formula for the current. The current starts off as 0 because this starts off as an open circuit and ends up as a short circuit. But when it starts off at 0, it's open, which means there's no current. Then as it induces more and more current, hence its name, the current goes up. And at 5 tau, it becomes E over R. This is a short circuit, so it's just a simple, it's like the inductor isn't even there. So I sub L equals E over R times the quantity 1 minus E to the minus T over tau. Tau is equal to L over R. And V sub L equals E times little e to the minus T over tau. VR is just IL times R, which ends up being E times the quantity 1 minus E to the minus T over tau. And I sub M is the final current, and that's the E sub R. It's the maximum steady state current after 5 tau. L is in inductance and henries, and time is in seconds. Time constant's also in seconds. So you could see the voltage here starts off as an open circuit, so it starts off as E because there is no current that has flowed yet, so it's in parallel. Basically, this resistor is not there because there's no current. It has no voltage drop, so V sub L starts off at E and it decays down to 0 after 5 tau per this formula right here. And then V sub R is just IL times R, so it looks very much like the current curve, only it's multiplied times R. That's V sub R, and it goes up to E after 5 time constants. So initial conditions, I sub L is equal to IF plus the quantity IL minus II minus IF times E to the minus T over tau. II is the initial inductor initial current. IF is the final current of the inductor, and as you can see in this graph, this is showing the initial conditions with II, and then the current gets induced up to IF. This is the difference. This is the transient portion, this is the steady state portion. So in this example here, when we close the switch, I sub L starts off at 4 milliamps given this, and then it decays down to 1.78. V sub L starts off as 0 because it's, again, at the initial time it's open, and then it goes to negative 20 volts, and then it decays down to 0. So with the transient release, putting it all together, you have your first circuit with the switch open, and at time 0 you close the switch. This inductor starts off as an open circuit. So right here you close the switch. The only part of the circuit that's involved is R sub 1, and when you open the circuit after it's fully charged, you have this circuit which it's discharging through. It keeps the same direction of the current. Current goes this way still, like it was going over here and here, but then the voltage flips because now this is pumping current this way. So that's why, let's go over these formulas. V sub L equals negative V initial times E to the minus T over tau prime, where tau prime is L over RT. And over here, tau prime is R1 plus R2. It should be L divided by the quantity of R1 plus R2. Well, and I don't know what happened there. Here we go. So, and then in the storage portion, which is up here, it's L divided by R1. So this is the charging phase, or the storage phase, where V sub L starts off at E and it decays down to 0 after 5 tau, and then it goes negative because it's pumping current the same direction. So really this is the plus side of it, but we're defining it this way, so it becomes negative and then it decays down to 0 after 5 tau prime. I sub L starts off at 0 and then it charges up. It goes up to its final value, and then it decays down in 5 tau, and then it decays down after 5 tau prime when the switch is opened. And likewise, you could see that the voltage across R1 looks identical to the current IL. It's just multiplied times R1. VR1 equals IL times R1, and then R2 has a steady state of 50 volts, which is E for this example. And then at the time that the switch is opened, after it's been closed for this amount of time, it also flips around and decays down because it's in parallel with V sub L.